All right, we're going to finish Unit 5, Lesson 10, up with problem set 10.3. And in this problem set, we're going to, at the end, talk about a pretty important fact about volumes of three-dimensional objects. So here we go. 10.3. Number 1, for each pair of solids, decide whether the volumes of the two solids are equal and explain your reasoning. So here on the left-hand side we have a cylinder, and on the right-hand side we have a what looks to be an oblique rectangular prism. So if we look at the cylinder on the left-hand side, notice the base area, right? This round circle here. It has a base area of 12 units. And then the height of this solid is 6 units. So you can think of this as having 6 total stacks of this area of 12. Okay, now let's look at the rectangular prism, the oblique rectangular prism on the right-hand side. Notice this base is this rectangle here. It's 4 by 3, so I know the base here is also 12. Now notice the height. The height is also 6, so we can think of this as having 6 of these bases that have an area of 12 all stacked up. So it makes sense that these two have the same volume. Okay, and here's why. At each height, the cross sections have the same area. Okay, so what we want to do is we want to look at the cross sections for each individual height as you move up, right? So if we take a cross section and we just take a slice right across here, notice that the area on the right here is going to be 12, and the area on the left here is also going to be 12. And that is true for every single cross-sectional slice that I take from the bottom all the way to the top. So they're going to have the same volume. Moving down here to number 2. Notice I have a base here that has a radius of 3. So the base area is pi times that radius of 3 squared. So my base area is 9 pi. On the right cylinder, same thing. I have a base area here that is 9 pi. Okay, so this oblique cylinder on the left has a base area of 9 pi. The right cylinder on the right has a base area of 9 pi. Let's look at the heights. Well, the height of the cylinder on the left is 7 units. So I have 7 of those 9 pi bases stacked up. However, on the right-hand side, notice I have a height of 10. So this has more of those 9 pi area bases, so these volumes will not be the same. So here we're going to have different volumes. There are more areas on the right cylinder. Okay, this oblique cylinder, remember the height, we always want to make sure our height is measured at a 90-degree angle. Okay, perfect. So these ones will have different volumes because there will be more of the bases stacked up on the right hand side. Moving down here, Notice number 3. So on the left-hand side, we have a square pyramid, right? The base area here is going to be the 5 times 5, or 25 square units. And on the right-hand side, we also have a square pyramid with a base area 5 by 5, or 25. Notice the left-hand pyramid here is a right pyramid, okay, because this height is inside, right in the middle. On the left-hand side, this one is oblique, but it still has the same base area. Now, if we think about taking this one on the right-hand side and turning it and flipping it so it's standing on its point, what I want you to think about is at every height, if we turn the one on the right-hand side upside down, at every height, they both have a height of 5, right? The 5 here and the 5 here. Both heights are 5. So at the same cross-section, right, on the same cross-section, they're going to have the same area. So these will have the same volume. And they'll have the same volume. Each cross-section will be congruent. Okay, fantastic. Moving down to number 4. Here we have a triangular prism kind of laying on its side here, right? We got this right triangle, and the base area is the 4 times the 3 divided by 2, because it's a triangle. So the base area here is 6. And we have a height. We have the height here is 5. So there are 5 of these base areas of 6 stacked on top of each other. Now on the rectangular prism on the right here, notice I have a base area of 6 times 1, or 6. Also notice that I have a height of 5. So at any cross section, right, if we start cutting cross sections there, or the cross sections here, each one of these cross sections is going to have the same area. So these will have the same volume, because each cross section is congruent, or has the same area. And there are the same number of cross sections. There are 5 in each. Okay, moving down to number 5 here, our last one. Let's take a look. We have this cylinder on the left. The base area is a circle, so it will be pi times that radius of 2 squared. So the base area is 4 pi. The cone on the right, same thing. I have a base of 4 pi. So let's take a look at what happens with the height. Notice my cylinder has a height of 6. My cone also has a height of 6. So far so good. However, if I start cutting cross sections, the only cross-sectional area that will be the same is the one on the very bottom down here. These are the only areas that are going to be the same. If I cut a cross section at a different height, notice that this area, that cross-sectional area, is going to be very different than this one. This one remains 4 pi. This one changes. I don't know how big it is, but I know it's not 4 pi. So this is not going to be the same. So these are going to have different volumes. because the cross sections are not all congruent. Okay, so those will have different volumes. Now, I said at the beginning that this was going to point out a very important idea behind volumes, and that idea is written up very nicely in the summary. So we're going to scroll down here, we're going to take a look at the summary. Here we have a stack of paper, rectangular prisms. We shift one stack and make it oblique. And notice the stack here on the left is a right rectangular prism, right? The one on the right-hand side here is oblique, right? Because that height falls outside. I can draw a height that's outside. These two will have the same volume, though, because every cross section, that sheet of paper, the sheet of paper on the left is going to be the same as the sheet of paper on the right. So if I take a cross section here, right here in the middle, if I cut out a cross section, the paper on the left will be the same as the paper on the right. So down here, this is the important information. Cavalier's principle. Okay, Cavalier's principle says if any two solids are cut into cross sections by parallel planes and the corresponding cross sections at all heights have equal areas, then the two will have the same volume. And we can see that in this example where we have the cylinder with a base area of 6 square centimeters, and we also have this and a height of 4, and we also have this square prism, right? This square prism if this is 3 by 2, right? If this is a square prism like this, notice each one of these areas will be 6 and will have the same amount. So when we cut them, they'll be the same. The two pyramids also have equal volumes because their bases are congruent and they have the same height. Shifting a solid from right to oblique will not change the volume, and this is all based on Cavalier's principle. This is kind of important, and in fact, it's so important that it is included in your reference chart for this unit. So that pretty much wraps it up for Unit 5, Lesson 10. If you have any questions, make sure you get in touch.